Hi folks. Recently in our History of Math course, we made use of a relationship between the inscribed angle in a circle and the corresponding central angle. And I assigned the proof of this fact that we used in class as homework, and a few students have asked me to provide some clarification about how to work through this proof. So I'll do that here in this video. So what we're going to do is break the problem up into a couple of different cases. The neat thing is that each of the cases is going to refer back to case 1. So case 1 is one leg of the inscribed angle goes through the center of the circle. So I have my center here at O. Now, this right here, that's the inscribed angle. I'm going to call that alpha. Okay, is that showing up? That's good enough. The corresponding central angle is right here, and we'll call that beta. Okay, so my goal is to prove that beta equals 2 alpha, or equivalently, alpha equals beta over 2. That's what I want to say. Okay, now, how do I get there? So, in this case, notice that leg is the radius of the circle. Okay, this leg of the central angle is the diameter, so this portion is the radius of the circle. And this is also the radius of the circle. So if I consider this triangle right here, this is an isosceles triangle. And what we're going to do is we will make use of a geometry fact there. The base angles of an isosceles triangle must be equal. Okay? This angle alpha opens up on the side R, so this angle must also be measure alpha because it opens up onto side R as well. Okay, so there's the inscribed angle. This is equal to the inscribed angle right there. So I guess the question becomes, all right, what is this angle? I'll just put a question mark right there. Well, we've got a triangle, so we know the measure of all the angles have to add up to 180 degrees. So we know that alpha plus whatever the measure of that other angle is has to be equal to 180. And another thing we know is, well, this angle right here, let me put some points on here. We'll call that A, we'll call that point B, and we'll call that point C. Okay? So angle BOC. Angle BOC is a straight angle. In other words, beta plus whatever value the question mark is equal to 180 degrees. Okay, so put these two together. This expression is 180. The sum of these three angles is 180. The sum of these two angles is also 180. So 2 alpha plus our unknown angle is equal to, has equal measure to beta plus our unknown angle. All right, so what we can do is subtract off the measure of the unknown angle and see that beta does equal 2 alpha, or equivalently, alpha is equal to beta over 2. All right? Now, the second case is the center of the circle is interior to our inscribed angle. Okay, so once again, we've got our inscribed angle, I'm going to call that alpha, and the corresponding central angle, I'm going to call that beta. Okay. Now here's the key step. What we're going to do is we are going to take an additional segment that goes through the center of the circle. Okay. And notice that has divided up my angles into two. I'm going to call those alpha 1 and alpha 2. It'll be beta 1 and beta 2. So my original inscribed angle alpha is equal to alpha 1 plus alpha 2. My original central angle beta is equal to beta 1 plus beta 2. Now, we were very strategic in adding the segment this way, because if I look at this angle, so let me add some points again. So the center of the circle, we'll call that O, that's A, that's B, that's C, we'll call this D. Okay, if I look at angle DBC, that is a inscribed angle with one of the legs going through the center of the circle for angle DBC. So according to that case, the measure of angle alpha 2 is 1/2 of the corresponding central angle DOC. In other words, angle alpha 2 is 1/2 angle beta 2. Now, of course, once again, you've got to remember my goal is the same thing. My goal is that I want to prove that beta equals 2 alpha, or equivalently, alpha equals beta over 2. So what I'm going to do is I'm going to apply case 1 to alpha 1 and beta 1, and also apply case 1 to alpha 2 and beta 2, since those two new angles that we created are covered under the previous case. All right, so I know from case 1 alpha 1 is equal to beta 1 over 2, and alpha 2 is equal to beta 2 over 2. Therefore, alpha, which we know is alpha 1 plus alpha 2, is equal to beta 1 over 2 plus beta 2 over 2, which is equal to, fractions already have a common denominator there. So this sum is equal to beta 1 plus beta 2 whole thing over 2, but beta 1 plus beta 2 is the central angle beta. Therefore, my inscribed angle alpha is equal to 1/2 my central angle beta. Okay, so that's how we deal with the second case. So we dealt with case 1. The center is on one of the legs of your angle. Case 2, the center of the circle is between the two legs of your angle. Case 3 is going to be when the center is exterior of your inscribed angle. Now, what we're going to do is we're going to, once again, refer back to case 1. Now, I'm actually going to let you finish off case 3 yourself, but I just want to show you the starting picture. So, let me grab my compass here, my chalkboard compass. So there's my center. This is a little unwieldy, but it gets the job done. Draws a fairly nice circle. I just have to watch myself and keep the point right on my center. That's why I like to draw my center before I start in with my compass. Okay. So there's my point O, the center of my circle. There's my inscribed angle. Let's call these points A, B, and C. Okay, now, it gets a little weird because the central angle is over here. Okay, so this is our original inscribed angle alpha. That is our central angle beta. Once again, what we do is we introduce a new line into the picture that goes through the center of the circle. Now, here's where we get a little clever. Okay, I'm going to call that alpha 2. Now you might say, okay, well, where's alpha 1? Alpha 1 is going to be up here. Okay, see that? I added that little orange thing. So my original inscribed angle alpha is alpha 1 minus alpha 2. It's the difference of the two angles. Same thing with this. We're going to call this beta 2. And here is beta 1. So my original central angle beta is beta 1 minus beta 2. Now once again, you'll notice the inscribed angle alpha 1 has a leg going through the center. So case 1 applies to alpha 1. In other words, alpha 1 is beta 1 over 2. And alpha 2 is an inscribed angle where one leg goes through the center of the circle. So case 1 applies. Alpha 2 is 1/2 of beta 2. So use that idea to finish off the proof.